very good morning, friends. Today we'll continue some more problems on Rolle's theorem and LMVT, Lagrange mean value theorem. This is lecture number 6. आज हम lecture number 6 start कर रहे हैं on Lagrange mean value theorem and Rolle's theorem. So let us start lecture number 3. पहले Lagrange mean value theorem क्या है? Rolle's theorem I have already explained.
यहाँ पे आगे में लिखो
Given an interval AB that satisfies hypothesis of Rolle's theorem, यानी एक इंटरवल AB में फंक्शन जो है रोल्स थ्योरम को सेटिस्फाई करता है. फंक्शन दिया हुआ है fx is equal to x raised to 4 plus x square minus 2. It is known that a is minus 1, then we have to find out b. Since fx x raised to 4 satisfies a Rolle's theorem, in closed interval AB, a is given to be minus 1. By condition of a Rolle's theorem, f of a is equal to f of b, f of minus 1 is equal to f of b, since a is minus 1. And what is f of minus 1? Minus 1 raised to 4 plus minus 1 square minus 2 is equal to b raised to 4 plus b square minus 2. This is 1 plus 1, b raised to 4 plus b square, and this will be 0. So b raised to 4 plus b square minus 2 is equal to 0. अब ये हो गया quadratic equation in b square. So we will solve according to quadratic. तो factorize 2 का ऐसा फैक्टर करना है कि सबट्रैक्ट करने पे 1 आए. 2 1 जा 2. ये लगेगा b raised to 4 b square plus 2 into b square minus 1. These are the factors. So b square plus 2 0 होगा और b square minus 1 0. b square plus 2 0 और b is what? Plus minus 1. But b square plus 2 is equal to 0 will not give any real root. Therefore, b will be plus or minus 1. Since a is minus 1, therefore b has to be plus 1. Verify Rolle's theorem for the following functions. In this fx is what? Sin x plus cos x plus 7. Since sin x cos x 7 are continuous and differentiable functions on their respective domains. Therefore, fx being sum of continuous and differential function, fx जो है सम है कंटिन्यूस और डिफरेंशियल फंक्शंस का, will be continuous on closed interval 0 to 2 pi and fx is differentiable on open interval 0 to 2 pi. Consider f of a, f of 0, sin 0 plus cos 0 plus 7, 0 plus 1 plus 7, 8. F of b is equal to f of 2 pi sin 2 pi plus cos 2 pi plus 7, 0 plus 1 plus. Therefore, f of a is equal to f of b. Hence, fx satisfies condition of Rolle's theorem. Therefore, there exists at least one C belongs to open interval 0, 2 pi such that f dash c is what? 0. Since fx is what? Sin x plus cos x, differentiating with respect to x. So f dash x is what? Cos x minus sin x plus 0. So f dash c will be what? Cos c minus sin c. Since f dash c is equal to 0 implies cos c minus sin c is what? 0. Cos c is equal to sin c. Tan c is 1. So c will be what? Pi by 4 and 5 pi by 4. And both the values lies in 0 to 2 pi. Fx is what? Sin x by 2. X belongs to 0 to 2 pi. Since sin x by 2 is continuous on and sin x by 2 is differentiable on open interval 0 to 2 pi. Consider f of a, f of 0, sin 0 is what? 0. F of b is what? F of 2 pi, sin 2 pi by 2, that is pi, is also 0. Therefore, fa is equal to fb. Hence, fx satisfies condition of Rolle's theorem. Therefore, there exists at least one C belongs to open interval 0 to 2 pi such that f dash c is what? 0. Since fx is what? Sin x by 2. Differentiating with respect to x, we get f dash x is what? 1 upon 2 cos. So f dash c क्या हो जाएगा? 1 by 2 cos c by 2. Since f dash c is 0, implies 1 by 2 cos c by 2 is 0. So cos c by 2 is 0. Cos c कहाँ 0 होगा? 90 degree और 3 pi by 2 पे. So this implies c by 2 is what? Pi by 2 or c is 3 pi by 2. C by 2. Therefore c is what? Pi or c is 3 pi. But 3 pi does not belong to does not belong to 0 to 2 pi. So c has to be pi.
एक मिनट डबल सर ये सब प्रॉब्लम मुझे लग रहा है कर दी है क्या
Next problem is what? Fx is equal to x square minus 5x plus 9. X belongs to 1, 4. Since fx is equal to x square minus 5x plus 9 being polynomial function, Therefore, fx is continuous on closed interval 1, 4. Also, fx is differentiable on open interval 1, 4. Consider f of a, f of 1 square minus 5 into 1 plus 9. One minus 5 plus 9 is equal to 5. F of b is what? F of 4 square minus 5 into 4 plus 9, 16 minus 25, 20 plus 9 is also 5. Therefore, f of a is equal to f of b. This implies fx satisfies Rolle's theorem. Therefore, there exists at least one C belongs to open interval 1, 4 such that f dash c is what? 0. Since fx is what? X square minus 5x plus 9. Differentiating with respect to x. F dash x is what? 2x minus 5. So f dash c will be what? 2c minus 5. Since f dash c is 0, so 2c minus 5 is 0. C is 5 by 8. If Rolle's theorem holds for the function fx is equal to x cube plus px square plus qx plus 5, Rolle's theorem यहाँ पे ट्रू है, सेटिस्फाई हो रहा है. x belongs to 1,3 और c की वैल्यू दी हुई है 2 plus 1 by root 3. Then the values of p and q are. Since fx is equal to x cube plus px square plus qx plus 5 satisfies a Rolle's theorem in closed interval 1, 3. Therefore, f of a is equal to f of b. So f of 1 is equal to f of 3. f1 हो जाएगा 1 plus p plus q plus 5. f3 will be 27 plus 9p plus 3q plus 5. 5 will get cancelled. So p plus q plus 1. Or transfer on that side. So 9p minus p is what? 8p. 3q minus q is what? 2q. 5 cancel 27 minus 1 is what? 26. Divide by 2. 4p plus q plus 13 is equal to 0. Equation number 1. Since c is what? 2 plus 1 upon root 3. Therefore, f dash c will be what? 0. Since fx is what? X cube plus px square plus qx plus 5. Differentiating with respect to x. So f dash x is what? 3x square plus 2px plus q. So f dash 2 plus 1 upon root 3. 3 into 2 plus 1 upon root 3 square plus 2p into 2 plus 1 upon root 3 plus q. But f dash c is what? 0. This is c. So 0 is equal to 3 into 4 plus 4 by root 3 plus 4p by root 3 plus q. Twelve plus 12 by root 3 plus 1 plus 4p plus 2p by root 3 plus q. Now we'll take 4p plus q plus 13. 13 together, and from equation number 1 its value is 0 plus 12 by root 3 plus 2p by root 3 is what? Now this value is what? 0 plus 12 by root 3 plus 2p by root 3 is what? So 2p by root 3 is what? Minus 12 by root 3. So p is what? Minus 6. We got the value of p. Since 4p plus q plus 13, therefore 4 into minus 6 minus 24 plus q plus 13. So q is what? 11. Hence p is equal to minus 6 and q is equal to 11. Rolle's theorem holds for the function fx is equal to x minus 2 log x. X belongs to 1 to 2. Show that equation x log x is equal to 2 minus x satisfies by at least one value of x in the interval 1, 2. Since fx is equal to x minus 2 log x satisfies a Rolle's theorem in 1,2. Therefore, there exists at least one C belongs to open interval 1,2 such that f dash c is what? 0. Since fx is what? X minus 2 log x. Differentiating with respect to x. X minus 2 into derivative of log x is what? 1 by x plus log x into derivative of x minus 2. Derivative of x minus 2 is what? 1 minus 0. X minus 2 upon x. So f dash c is what? C minus 2 upon c plus log c. F dash c is 0. Therefore, c minus 2 upon c plus log c. C minus 2 is what? Minus log c. So c minus 2 is what? So 2 minus c is what? C log c. And c is what? At least 1 in the interval. This implies 2 minus x is equal to x log x is at least 1. X belongs to open interval 1 to 1. The equation fx is equal to x into x plus 3 e raised to x minus x by 2 satisfies all conditions of Rolle's theorem on closed interval minus 3, 0. Find the value of c such that f dash c is 0. Since fx is what? X into x plus 3 e raised to minus x by 2. Satisfies Rolle's theorem in closed interval minus 3, 0. Therefore, there exists at least one C belongs to open interval minus 3, 0 such that f dash c is 0. Since fx is what? X into x plus 3 e raised to minus x by 2. इसको और सिंपल करने के लिए हम इसको मल्टीप्लाई कर ले रहे हैं. x square plus 3x into e raised to minus x by 2. Differentiating with respect to x, u into v, x square plus 3x, derivative of e raised to minus x by 2 is what? So derivative of e raised to minus x by 2 is what? Minus 1 by 2 e raised to plus derivative of x square plus 3x is what? 2x plus 3. So we can take e raised to minus x by 2 common. In bracket you will get 2x plus 3 minus x square plus 3x upon 2. So f dash c will be what? E raised to minus c by 2. 2c plus 3 minus c square plus 3c upon 2. Since f dash c is 0, therefore e raised to minus c by 2 into bracket 2c plus 3 minus c square plus 3c upon 2. But e raised to minus c by 2 can never be 0. So 2c plus 3 minus c square plus 3c upon 2 has to be 0 since e raised to minus c by 2 cannot be 0. So 4c plus 6 minus c square minus 3c. So minus c square plus c plus 6 is equal to 0. C square minus c minus 6 is equal to 0. Factors are c minus 3 into c plus 2 is equal to 0. So p is equal to 3 or c is equal to minus 2. But c is equal to 3 does not belong to minus 3 comma 0. And c is equal to minus 2 belongs. So c is equal to minus 2. Lagrange's mean value theorem, LMVT. Let fx be a real valued function defined on closed interval AB such that number 1, fx is continuous on closed interval AB. Number 2, fx is differentiable on open interval AB, then there exists at least one C belongs to open interval AB such that f dash C is what? F of B minus f of A upon B minus A. Let me explain this. This is a curve. Y is equal to fx. This point is what? P A comma f of A. This point is what? Q B comma f of B. This is B and this point is what? A. So we'll get this is chord AB. So slope of chord AB is what? FB minus FA upon B minus A. In this case, there exists at least one C in this interval, so that the tangent at this point is what? Parallel to B. Tangent is parallel to AB. This is point C. Tangent at point x is equal to C is parallel to chord AB. Therefore, slope of tangent at x is equal to C is equal to slope of chord AB. So f dash C is equal to FB minus verify Lagrange's mean by a theorem for the following functions. Fx is what? Log x on the interval 1 comma e. Since fx is equal to log x is continuous on closed interval 1 comma e, also fx is equal to log x is differentiable on open interval comma e. Therefore, fx satisfies LMVT. That is Lagrange's mean value theorem. Therefore, there exists at least one C belongs to open interval 1, E such that f dash C is what? F of B minus f of A, B minus A. Since fx is what? Log x. Therefore, f dash x is what? 1 upon x. So f dash C is what? 1 upon C. F of B is what? F of B is what? F of E log E, which is 1. F of A is what? F of 1 log 1, which is 0. Since f dash C FB minus FA upon B minus A, FB is what? 1 minus 0 upon E minus 1. So C is what? E minus 1. So next problem is what? Fx is equal to x minus 1, x minus 2 into x minus 3 on 0 to 4.
Yes.
Since fx is equal to x minus 1, x minus 2, x minus 3 is a polynomial function. Therefore, fx is continuous on closed interval 0, 4 and fx is differentiable on open interval 0, 4. Therefore, fx satisfies condition of LMVT. Therefore, there exists at least one C belongs to open interval 0, 4 such that f dash C is what? FB minus FA upon B minus A. Since fx is what? X minus 1, x minus 2, x minus 3. Differentiating with respect to x. f dash x is what? X minus 1, x minus 2 plus x minus 1, x minus 3 plus x minus 2, x minus 3. Which is same as 3x square minus 3 minus 4 minus 7 minus 5 minus 12. 2 plus 3, 5, 5 plus 6, 11. So f dash c will be what? 3c square minus 12c plus 11. F of b, f of 4 will be 4 minus 1, 4 minus 2, 4 minus 3. Is equal to, this is 3 into 2, 6. F of a, f of 0, 0 minus 1, 0 minus 2, minus 6. Since f dash c is what? F of b minus f dash c is what? 3c square minus 12c plus 11. F of b is what? 6. Minus of minus 6 upon 4 minus 8. So 3c square minus 12c plus 11. 12 by 4. 3c square minus 12c plus 11. 3c square minus 12c plus 8. 24. 8 is 12, 12 is 24? No. So c will be what? Minus b plus minus root b square minus 4, 3 are 12, 8 are 96 divided by 2 into 3. So c is what? 12 plus minus. This will be 48. Root 48 is what? Upon 6. We can divide this. So c is what? 2 plus or minus 2, 2 jar 2, 3 jar. So root 3. So 2 upon root 3. 2 minus 2 by root 3 also lies in 0 to 4. And 2 plus 2 by root 3 also lies in 0 to 4. So these are two values of c. Next problem is fx is what? X square minus 3x plus 1. Since fx is a polynomial function, therefore fx is continuous on closed interval minus 11 by 7, comma 13 by 7, and fx is differentiable on open interval minus 11 by 7, comma. Therefore, fx satisfies condition of ln Vt. Therefore, there exists at least one C belongs to open interval minus 11 by 7, comma, such that f dash C is what? F of b minus f of a upon b minus a. Since fx is what? X square minus 3x minus 1. So f dash x will be what? 2x minus 3. So f dash c will be what? 2c minus 3. F of b is what? F of 13 by 7 is equal to 13 by 7 square minus 3 into 13 by 7 plus minus 1. 169 by 49 minus 39 by 7 minus 1. LCM. 169 minus 7 will get multiplied to 273 minus 49. 273 minus 153 upon 49. Now find out f of a. F of a is what? F of minus 11 by 7 minus 11 by 7 square minus 3 into minus 11 by 7 minus 1. 121 upon 49 plus 33 upon 7 minus 1. 49 LCM. 121 plus 231 minus 49. 253. 352. 303 upon 49. Now f dash c is what? f of b minus f of a upon b minus a. F dash c is what? 2c minus 3. F of b is what? Minus 153 upon 49 minus 303 upon divided by 13 by 7 plus 11 by 7. Will give you what? Minus 456 upon 7 into 24. Will give you 2c is what? Plus 3y minus 456 upon 168 plus 3, which is minus 456 plus 2c is what? 14 minus 6 is 8, 9, 456 plus 44 is 648. 9 minus 5, 4 upon 268. 168, sir. So this implies C is equal to 24 upon 168 will give you 1 by 7. So C is what? 1 by 7. Fx is equal to 2x minus x square. Fx is 2x minus x square. Since fx is a polynomial, polynomial function, therefore fx is continuous on closed interval 0, 1 and fx is differentiable on open interval 0, 1. Therefore fx satisfies ln Vt. Therefore there exists at least one C belongs to open interval 0, 1 such that f dash c is what? F of b minus f of a upon b minus a. Since fx is what? 2x minus x square. Differentiating with respect to x. F dash x is what? 2 minus 2x. So f dash c is what? 2 minus 2c. F of b is what? F of 1. 2 minus 1 is equal to 1. F of a f of 1 for f of 0. And f of 0 is what? 0 minus 0. Since f dash c is what? fb minus fa upon b minus a. F dash c is what? 2 minus 2c. F of b is what? 1 minus 0 upon 1 minus 0. So 2 minus 2c is what? 1. 1 is equal to 2c. So c will be what? 1 by 8. Between 0 and 1, 1 by 2 lies. Next is what? Fx is x minus 1 upon x minus 3. Being ratio of two polynomials. Therefore, fx is continuous on 4 to 5. It is discontinuous only at 3. But 3 is not in this interval. So it is continuous at 4 to 5. Also, fx is differentiable on open interval 4, 5. Therefore, fx satisfies L and Vt. Therefore, there exists at least one C belongs to open interval 4, 5 such that f dash c is what? F of b minus f of a upon b minus a. Since fx is what? X minus 1 upon So f dash x is what? V square. V into derivative of this is what? 1 minus derivative of x minus 3 is what? So f dash x is what? X minus 3 minus x plus 1. So minus 2 upon x minus 3 square. So f dash c will be what? Minus 2 upon c minus 3 square. What is fb? F of b is what? F of 4. 5. 5 minus 1 upon 5 minus 3. 4 upon 2 is equal to 2. F of a is what? F of 4. 4 minus 1 upon 4 minus 4 minus 1 is what? 3 upon 2, 3 upon 1. Since f dash c, fb minus fa upon b minus a, so minus 2 upon c minus 3 square, fb is what? 2 minus 3 upon 5 minus 4. So minus 2 upon c minus 3 2 minus 3 is minus 1 upon 1, so minus 1. So minus will get cancelled, so 2 is equal to c minus 3 square. So c minus 3 is what? Plus minus root 2. So c is what? 3 plus minus root 2. But c 3 plus root 2 belongs to 4 to 5. But c is equal to 3 minus root 2 does not belong to 4 to 5. So c is equal to 3 plus root 2. Thank you very much. Success is not final and failure is not fatal. सफलता ही अंतिम चरण नहीं होगी, अंतिम स्टेट नहीं होगा, और असफलता कोई मरण जैसा नहीं होगा. It is the courage to continue that counts. ये आपकी हिम्मत होगी जो आगे बढ़ाती जाएगी, काउंट करते जाएगी. थैंक यू.